Welcome to a lesson on variance and standard deviation. This is lesson 3 in probability distributions. So let's get started. All right. So in the previous lesson, we developed the idea of expected value or the mean value, the expected score when you do an experiment, a discrete random variable. All right, so when we toss 4 coins and we want to know the expected number of heads, we can draw the following table. Okay, and this is what we're up to. The first row, we write down all the possible outcomes. In the second row, we write down the probability associated with each of those outcomes. And in the third row, we just multiply the first 2 rows, then we sum up all of the values to get our expected value. And we say that the expected value in this case is 2. Now, variance is a study of how spread out the values are from this expected value of 2. How spread out are all of the values? And let me give you a simple example of this. You could have, let's say you had a maths exam, you had an English exam, and someone got 50% in maths and 50% in English. Now, this 50% doesn't really tell us much information on in and of itself, because for example, I'll list some possibilities and you'll see why the 50% mark doesn't really tell us anything. Let's say, for example, in maths, I got 50%, but everyone else in the class got 10%. Now, if I just told you I got 50%, you don't know how everyone else did. And similarly, another possibility might be that I got 50% and everyone else got 47%, 48%, 49%, 51%, 52%, 53%. And so how spread out are the scores? Not very spread out. They're all around 50%. And that gives me a different situation now. That gives me a different idea of how I did. On the other hand, a third situation might be, for example, that someone got 10%, 30%, 40%, 60%, 70%, and 90%. That could be the spread of scores. And now the 50% takes on a completely different meaning. So as you can see, just telling someone what score they got, or even the average value of the class, if the average of a class is 50% of the it doesn't really tell us much. Because if the average of the class is 50%, but everyone's marks were between 45 and 55, that tells us one thing. But if the average of the class is 50%, but everyone's marks, 10%, 20%, 30%, they're really spread out, that gives us a different image of how the class did. And so we need more information. How spread out are the scores? And that's what variance is. That's why we do variance. Variance is a study of how spread out the values are from the expected value, from the mean, from the average. How spread out are the values? And we write this as var of x. And 1 second. Let me share my screen again. And there we go. Sorry about that. All right, so continuing on. In the previous lessons, okay, that's what we just did. So we write this as var of x. And to find the variance, we measure how far a score is from the mean, from the average, from the mean. And we find the difference of each value from the mean. And this was give us deviation. So what that means is, let me pull out my pen. This is the expected value. That is the mean, the average, so to speak, of the probability distribution. What we're now going to do is we're going to say how far away from the mean is each of these values? How far away is this from the mean? So we do the difference between 0 and 2, and then we write 2. The difference between 1 and 2, we write 1. The difference between 2 and 2, we write 0, and so on. So we're trying to find out the distance of each score from the mean, from the expected value, from the average. How far away is it? Then
Bit
we
far.
square those distances. Why do we square them? Because we're trying to find a measure of how far away, how spread out the scores are. And when you square a big number, it gets really big. And when you square a small number, it gets even smaller in some ways. Like if it's less than 1, I guess. But a small number, if you square it, doesn't really change by that much. And that's really what we want. We want to exaggerate the numbers that are really far away to tell us that, hey, they're very spread out. Scores are very spread out. And if the scores are not spread out, then when we square them, it won't really change them so much. You know, if for example, if all the scores are spread out by 1, we square 1, you're gonna end up with 1. It doesn't change, and that's why we square them, and that will give us a good picture of variance. Any questions?
What about 3 and 4?
What about the 3 and 4? Yeah, obviously we do it for those as well. What's the difference between 3 and 2? 1. What's the difference between 4 and 2? 2. And then we'll square these. We'll square these and we'll get 4, 1, 0, 1, 4. And notice how the scores which are really far away got exaggerated.
But why did you
And
do
the
that?
scores which are close up didn't really change by that much.
So why do you square it?
Pardon?
Why do you square it?
Well, I just explained that we square it because squaring exaggerates bigger values, telling us a score is far away from the mean, and understates smaller values, telling us something is close to the mean, giving us a good picture of variance. See, my aim, so if you look over here, my aim, variance is a study of how spread out the values are from the expected value of 2. Variance tells us variance is going to be a number. You know how we said expected value is 2? We are saying E of X is equal to 2. And that tells us that if we conduct, if we conduct this experiment, then the expected number of heads is going to be 2. That's what we expect. E of X equals to 2. Now we want another statistic to tell us how spread out the scores are. Does that make sense? How spread out the scores are? Do you understand what I mean by that?
I don't know, probably.
Okay, so I gave the example a bit earlier. Let's say you guys do a test. And the average is 80%. Now, there's a few different possibilities. When I say the average is 80%, it's possible that everyone got 78, 79, 80, 83, 84, 84, or whatever. I'm assuming this is not actually an average of 80. Yeah, but let's say 75. And yeah, I don't know. Just pretend the average is 80. Okay, now if I told you the average is 80, that's one set of scores which are possible. Yes?
Yeah.
Another set of scores that's possible is that it was possible to have gotten that's also possible. The average will still be 80. Yes or no?
Yeah.
So when you go into your parents, the average is 80%. And your parents don't really know, no one really knows what that means in terms of how spread out. You need to know how spread out the scores were. If you got 80% over, over here, it's probably a bit better than that 80%. Because the average is 80 in both, but over here, they're very, really, really close together. Everyone got around 80 anyway. Over here, not many people got around 80, like, half the class got way less. Does that make sense?
Yeah.
Yeah, like talk to me. You gotta talk to me. I'm the only one talking. I don't know what you're thinking. What's confusing you?
Nothing.
Sir, do you want me to talk to
We're
you?
trying to understand.
I'm trying to understand.
Sir.
Yeah, so talk to me. Like you're not really clear. So tell me what you're not clear about. What's confusing you? What's going on?
So it's better to get the average of 80 in the first one than the second one because it's more
No.
evenly distributed.
Don't be silly. Don't be silly.
Huh?
Sorry, the first one, everyone's close together. So like you getting 80 is similar to you getting 78, which is last. 75 is last. However, in the second one, last place is 60%. So you're in the middle percentile here. And in the first one, like middle doesn't really matter because it's like 2 marks apart. Maybe I forgot to write a plus sign, minus sign.
See, the point really is that we need to know how spread out the scores are. That's the point. Don't worry about the marks too much. The point I'm trying to make is they're different. 80% over here and 80% over here are different. Do you agree?
Yeah.
And they're different because of the spread of scores. Yeah?
Yeah.
Because when the scores are really, really spread out, it's different to when the scores are really, really close together. And so we need a mathematical value to tell someone how spread out the scores are. That's what I'm trying to say here. That's what we're doing today. We are doing variance today. Variance is the mathematical tool we use to express how spread out scores are. That's all you need to know. We just use variance. Variance is going to be a number, and we're going to look at how to calculate it in a second. But the point is, variance will tell us how spread out scores are. Okay, so let's move to the next slide. How do you calculate variance from deviance squared? Let's just calculate variance. Let's update our table with the square of the deviation. So all I've done over here so far, you know the first 3 rows. Do I need to explain the first 3 rows? That was the homework yesterday.
Nah, first 3 rows are good.
All right. So now what we're doing in the 4th row is we are calculating deviance. Deviance is how far away is a score from the expected value. And we square that. So how far away is 0 from 2?
2.
2 or -2. It doesn't matter because you're going to square it. Okay, so x minus mu, x minus expected value, 0 minus 2 is going to give you -2, but you square it, you get 4. Okay, so how far was 0 from 2? It was 2 units away. We square it, you get 4. How far away is 1 from the expected value? It's 1 distance away. You square 1, you end up with 1. Any questions about the process?
Nope, we just square it half the distance from 2.
That's simple.
Yeah, so all we're doing is how far away is the score from the mean, and then you square that result.
Yes. So we got
Square
it. Got it.
This is deviance squared. This is deviance squared, okay? Now we're gonna weight these new row values by the probabilities to give variance. So what we're gonna do now is we're gonna do whatever this was multiplied by the probabilities. Yeah, and you write it
Yeah.
everything. And you multiply this with that to give you that. Multiply this with this to give you that. And you sum these up, and that will give you variance. Yes, any questions?
No, that's simple. What's so
Okay.
what's so hard about that?
Wait, what was the last part? I got distracted by someone.
So did
Just
you get up to
multiply.
here? Did you
Yeah,
get
I
up to this? Did you understand everything
I
to
understand everything
there?
until the last row. The last row we var.
Okay.
The last row
Fair
just
enough. That's
multiply.
okay. In the last row, we get this value and we multiply it by that value.
Ah, simple.
So
That's
you
it. Got
get
it.
this multiplied by that. I've color coded it so you can see,
Yeah,
right?
got it.
The orange multiplied by the pink, orange multiplied by the pink. That's all we're doing here.
So it's easy.
Right? And then you sum up these, you add all of these up, and you'll get 1. And that's our variance. Variance is equal to 1. Yeah. Now remember,
Perfect. So
variance tells us how spread out the values are. Gives us an indication of how spread out the values are. Yes?
yep, got it.
All right, moving on. All right, so in a game of chance, a player spins a square spinner labeled 1 to 34. The player wins the amount of money shown in the table below, depending on which number comes up. The expected return is $4, as in the table below. Calculate the variance. So let's say we have this. Walk me through it, someone, anyone. Walk me through it. What do I do now?
So
What's
first,
the next thing to do?
you look at the distance. 1 is from 4,
Which
so
is
that which is 3. So you chuck a 3 there. Then the distance.
no, you don't write 3. You write 3 squared, which is
3. Okay, instead of skipping steps, so it'll be 3 squared, which will be 9.
Okay, 9. What do I do over
And
here? Isaac?
Yes, sir.
Yeah, what do I do? What do I write here? What do I write?
Oh, easy. What? Basically, so x minus, so u is 4, so x is 2 minus 4 is just 2 squared is 4.
4. Right, 4 here. Half. What do I write over here, Salman? And the next over here, what do I write?
You write whatever you want to write.
Come on.
Sir, I already know how to do it. Like, I'm gonna learn from the
Then do
textbook.
it. Then do it.
Sir, I'm playing games right now.
Salman, please focus on the lesson.
So
Sir,
same thing.
because sir, you said you're recording the lesson. So if I can't contribute to the lesson, then I won't be able to
You
learn. So
can.
I'll learn from the textbook.
For heaven's sake. 5 minus 4 is 1. 1 squared is
Yes,
1.
it's simple. It's so
And
simple.
8
Then
minus 4 is
I do know
4.
how to do it. Sir,
16.
it's pink minus orange, and you just square it.
yeah, so we're
All
not
right,
saying
what do
we
I
get
do
too much
next?
there.
What's that next row? What
The
do I do
next one
next
you
after
multiply.
that?
You multiply 9 times 1/4. So that would be 9/4.
9
And
times 1 over 4
and
gives
then
you 9 over 4.
yeah. And you just do the same
What do I
thing.
do
So I got it,
next?
but I'm just like really dead right now.
4 multiplied by a quarter gives
1/4
us
is 1.
1.
1. Then 1 times 1/4 is 1/4. Then 16 times 1/4 is 4.
4.
Yeah,
Okay,
that's
and then
it,
what do we
that's
do
it.
after that?
The next thing. Wait, what was after that?
Add them up.
Add what
Yeah,
up?
add 'em up.
Yeah,
You get
add them
what?
up. So it's 9/4 plus 1 plus 1/4 plus 4, which will be 10/4. 1 10/4 6 5.
7.5.
7.5.
Okay, there you go. That's it. So I got it. I'm just
Okay, that's
really-
how you find variance of x. Okay.
Hmm.
Moving on. Variance as an expected value. So that's the variance. Okay. If you examine the last row, we summed up all the values and got our result. The total variance was equal to 1. Now the way to think of this is that the variance is just the expected value of x minus mu squared. So this is another formula that you end up using sometimes. Variance of x, you can think of it as expected value of x minus mu squared. Just keep that in mind, I guess. But just understand the main sequence. All right, standard deviation. Now move from variance to standard deviation. The two are linked. Standard deviation is the square root of the variance. Okay, standard deviation, square root of the variance. That's it, simple definition. And we write standard deviation using lowercase sigma. This sigma S stands for standard deviation, S for standard. Okay, and you can write this in two ways. Sigma is equal to square root of variance of x, or sigma squared is variance of x. Same thing, really. They're the same thing. Now, standard deviation is similar to variance in that they're both used to measure spread. However, why do we prefer standard deviation? Well, because remember how we squared earlier to find variance? We squared our numbers.
Yeah,
When
so
we
you just
square
reverse it.
numbers, then the unit kind of changes, right? And when we square root it back afterwards, we now have our original units, if that makes sense. And that helps us get a more intuitive sense of how spread out the scores are. For example, if we do a test, a class test that's out of 100, percentages, let's say, and someone gets 50, 60, 70, you have a bunch of scores, 50, 60, 70, 80, and so on and so forth. And to find the variance, you're going to have to square the differences. When you square it, your standard deviation, your variance might be something like 25. What does that mean? It's hard to see. But if you square root the 25, because we squared it, remember we squared it initially. So if we square root it, we have our normal units again. So when I say standard deviation is 5, you can relate it directly to your own scores. I guess when you do questions, you'll understand it a lot more. Okay, main idea of this slide. Standard deviation is the square root of the variance. So when we're learning how to do variance, calculate variance, just square root the variance, you'll get standard deviation. All right. Moving on. So for example, The game of chance, a player spins a square spinner, blah, blah, blah. Same question as before. We found the variance of 7.5. What is the standard deviation?
So you square root 7.5.
Square root it, and you get square root of 7.5, which is 2.74. That's
it.
pretty much it.
That's it, sir.
Sweet.
And standard deviation versus the mean, we can compare two scores from unrelated experiments using standard deviations and the mean. This is interesting. I can almost guarantee it's going to be in the HC because it is common with the standard course. So standard students do it, and 25% of the HSC exam is going to be the same between standard maths and advanced maths. Let me repeat that. In your HSC maths advanced exam, 25% of it is guaranteed, like the questions, 25% of the questions are guaranteed to be perfectly identical to 25% of the questions in the Math Standard 2 exam. And that means you should be focusing a lot on the shared questions, on the shared topics, because you know for a fact that they're going to be in it, pretty much. Like probability. Probability is definitely going to be in it because probability is in the standard course. It's also in the advanced course. Same thing as
what's
this
the
particular slide.
probability? So what's the
Pardon?
probability of it not being in it?
Very low.
So draw a tree diagram.
No, thank
And
you.
use it.
We can, okay, so here, so listen carefully. Otherwise, it's going to fly over your head and you'll be left very confused. If the standard deviation is 2 and the mean is 3, then a
Yeah.
score of 5 is 1 standard deviation above the mean.
Oh,
So let's say, for example, you have a bunch of scores and
Yeah.
I'm going to, let's say that's the scores, right? 100. And let's say, oh no, 100. Okay, so let's say it's
69.
out of 10. Let's say it's out of 10 and this is 0. And I'm telling you the mean is 3. So that's a 5. And let's say 1, 2, 3, 4. And I'm saying the mean is 3. I'm saying the mean is 3. The average is 3. And then I
Yeah,
say the
bro.
standard deviation is 2. Standard
Yeah.
deviation is 2.
Yeah.
Then
Yeah.
a score of 5. If Salman got 5 out of 10, then Salman is 1 standard deviation above the mean because standard deviation
It's 2.
Oh, so
equals
it's
to 2.
yeah.
So how many standard deviations above the mean is Salman? 1
One.
standard deviation above the mean. 3
Sir,
plus 2 is
sir,
5.
now I know why this chapter is so easy because it's in general math. I was like, bro,
Well,
this is
only this
so
slide
easy.
is in general maths, not the previous slides.
What you
General
just said,
maths,
20,
general maths does do
25%.
standard deviation, but they use a calculator. They don't need to do. They don't need to draw a table.
I
At
saw
all.
mine. It's recorded, so we have proof.
Oh, sir, I'm gonna get you on that.
What?
Nothing.
Okay, I don't know what you're talking about. All right, and if you have another score of 7 in a distribution, the standard deviation is 1.
deviation. 2 deviation.
No, it's 1.
If we have another
Oh.
score of 7 in a distribution, where the
Oh,
standard deviation
yeah.
is 1 with a
Yeah,
mean of
yeah, yeah.
6.5, we can compare these two scores.
0.5
Please make sure you understand
deviation.
this.
0.5.
If you have a test, listen, please. If you have a test
Yeah.
for business studies and you have a test for mathematics and you get 50% in maths and you get 80% in business, then you can't compare the two scores directly. It's you just can't. It's like comparing apples and oranges. You can't do that. However, you can compare the standard deviations. So if in maths you got 50%, but you actually came first, and in business studies you got 80%, but you came last, what did you do better in?
Mathematics.
Maths, because you came first in maths. That's the general idea. So standard deviation tells you how far above or below the average you were. And you
Great.
can compare that. You can compare that between subjects to find out what your actual best subject is.
Oh, strong.
Hopefully that makes sense. It's very useful. And in fact, the HSC and your ATAR or whatever it's called now, yeah, your ATAR, at 100% depends on the stuff in this slide. This is exactly what they do. They look at standard deviations, and that's how they calculate your ATAR and so on. How else are they going to compare? This is how subjects are scaled, by the way. Scaling has got to do with this stuff as well. Because how can you compare math standard and maths advanced? They had two different exams. They had a different syllabus. How can you
Sir.
compare them? Well, they
Sir.
compare them using standard deviations.
So yesterday there was a question. There's an ATAR and then blah, continuous, discrete. So these Donnies, they said, all right, so ATAR is discrete, right?
Yeah.
But isn't it continuous as well? Because if someone got 99.95 and they did the exact same subject, but someone got 0.1 in business and the other guy got 0.1 in biology and they got the same mark. So is that still discrete?
I've got no idea about the example you just gave, but it's discrete because it's countable. You get 99.95, 99.90, 99.85, 99.8.
But
You
isn't
cannot
it
get
rounded up? Isn't it rounded up?
no.
Ah.
It's a
What?
ranking, and there's
Oh
only
yeah, it's a
certain
ranking. It's a
numbers.
ranking.
There's
Yeah,
only
now I
certain
got it.
numbers you can take. Continuous distributions can be absolutely anything. So if for example, it was possible to get an ATAR of 99.135799357999543, then it would be continuous.
Okay,
But it's
boss.
not. There's only a certain number of values you can take. Anyway, coming back to the question, if you have a score of 7 and a distribution with a
God.
standard deviation is 1 with a
Man.
mean of 6.5, so the average is 6.5, standard deviation is 1, and someone got 7. So did you do well? No, because you're only half a standard deviation above the mean. Let's say high scores are better, then a score of 7 would be better than a score of 5. However, the score of 7 is only half a standard deviation above the mean. While the score of 5 is 1 whole standard deviation above the mean. This means the score of 5 is better relative to the whole cohort.
That is actually interesting.
Yeah, it is. But that's it for today, by the way. So I'm gonna stop the recording here, and you guys can ask me questions, and we
Yeah,
can
I
look
have to
at
ask
some
the
more
question.
examples, perhaps.